Welcome to my algebra class. We're working on Chapter 9, Section 7, and these are puzzle problems. There are three types of problems you're going to encounter. The first type is a digit problem, where we're trying to find a missing digit. The U will stand for the units digit, the T the tens, and the hundred the H a hundreds digit. If they talk about the value of a two-digit number, in base 10, if I have a number like 34 that says 3 tens, so 10 times t, the digit being 3, plus 4 ones. So 10 times 3 plus 4. So this is how I would write the value of a two-digit number. The value of a three-digit number, if I have 346, that's 100 times 3 plus 10 times 4 plus 6 times 1. So that's how we write a three-digit number, the value of it. We're also going to be working with age problems. Sometimes they'll be asking about the age in the future or maybe the age in the past. This is an example of the age in the future, 5 years from now. And then finally we have fraction problems, where we're going to let n stand for the numerator, d for the denominator, read carefully, and set up the problem based on what they tell us. So with that in mind, we're going to do the evens, and hopefully you'll catch on to what we're doing here. Problem number 2. Write an equation expressing each fact. It says the sum of the digits of a three-digit number is 10. Well, the digits of a three-digit number are H, T, and U. The hundreds digit, the tens digit, and the U, the units digit. So the sum of the digits, H plus T plus U, equals 10. Number 4, a three-digit number is 16 times the sum of its digit. They're actually talking about the value of a three-digit number, so that would be 100H plus 10T plus U. The three-digit number equals 16 times the sum of its digits, H plus T plus U. Number 6, when the digits of a three-digit number are reversed. Well, a three-digit number is 100H plus 10T plus U. If I reverse the digits, switch the H and the U, I get 100U plus still 10T plus H. So it says when the digits of a three-digit number reverse, the new number is 198 less than the original number. So the new number is 198 less than the original number. So here's the original number minus 198 equals our new number with the digits reversed. Problem number 8. Solve each of the following problems using about two-digit numbers. The sum of the digits of a two-digit number. The sum of the digits of a two-digit number would be T plus U. Is 1/3 the number. 1/3 the number would be the value of the number 10T plus U. It also says the units digit is 5 more than the tens. So I have a system here, and I'm going to use substitution. Where I see U over here, I'm going to plug in 5 plus T. So T plus 5 plus T equals 1/3 times 10T plus 5 plus T. I'm going to simplify. I have 2T plus 5 equals 1/3 times 11T plus 5. I'm going to get rid of the 3. I'm going to multiply both sides by 3. Get rid of the fraction, rather. So I get 6T plus 15 equals 11T plus 5. Getting the T on one side, I'm going to subtract 6T. From both sides, I get 15 equals 5T plus 5. Solving for T, subtract 5. I get 10 equals 5T. Divide by 5, and I find out that the tens digit of the number is 2. And I go back and I plug it into u equals 5t. So u equals 5 plus 2, which is 7. So what was my number? The tens digit was a 2, and the units digit was a 7, so the number is 27. Problem number 10. When the digits of a two-digit number are reversed, the new number is 54 less than the original number. So start with the two-digit number, 10t plus u. The digits of a two-digit number reversed, the new number is 54 less than the original number. So the new number would be 10u plus t. And it's 54 less than the original number. And it also says the sum of its digits is 8. So t plus u equals 8. And I'm going to use substitution again. I'm going to solve for t. So t equals 8 minus u. And I'm going to plug this in over here. So wherever I see a t, I'm going to put an 8 minus u. So this is 80 minus 10u plus u minus 54 equals 10u plus 8 minus u. Collecting like terms, 80 minus 54 is 26, and negative 10u plus u is negative 9u. 10u take away u is 9u plus 8. So I'm going to add 9u to both sides. Get my variable on one side. I get 26 equals 18u plus 8. Subtract 8. I get 18 equals 18u. Divide by 18. And I find out that my units digit is 1. Plug that back in here. The tens digit is 8. Take away 1, which is 9. So my number, tens digit's 9, the units digit is 1. Excuse me, it should be a 7. So the tens digit is 7, and the units digit is 1, so my number is 71. Problem number 12 is an age problem. Cecilia is 24 years younger than Joe. So I'm going to let J equal Joe's age, and C equals Cecilia's age. And one equation I can write, Cecilia is C equals 24 years younger than Joe. Joe's age minus 24. It says 6 years ago. So her age 6 years ago would be C minus 6. She was half as old as he was 6 years ago. So Joe's age 6 years ago would be J minus 6. So if I substitute in wherever I see a C with J minus 24, since this is already solved, ready for substitution, I get J minus 24 minus 6 equals 1/2 J minus 3. So that's J minus 30 equals 1/2 J minus 3. Multiplying by 2, I get 2J minus 60 equals J minus 6. Subtract J from both sides. I get J minus 60 equals negative 6. Add 60, and I get J equals 54. So Joe is 54 years old. And Cecilia was 24 years younger. So 54 minus 24, she is 30 years old. Number 14. Okay, we have Marion and Les. Marion, M equals Marion's age. And L equals Les's age. So 4 years ago, Marion was two-thirds as old as Les was. So Marion's age 4 years ago would be m minus 4, and that meant she was two-thirds as old as he was then, back then. So L minus 4. Right now Marion is 3/4 as old as he is. 3/4 L. So if I substitute that in, I get m minus 4 equals 2/3. Wait a second. Substitute in for m, 3/4 L. Times L minus 4. I'm going to multiply both sides by 12 to get rid of the fractions. So 4 goes into 12, 3. That'd be 9L minus 48, distributive property. 3 goes into 12, 4. 4 times 2 is 8 times the quantity L minus 4. So I have 9L minus 48, distributive property 8L minus 32. Subtract 8L from both sides, and I get L minus 48 equals negative 32. Add 48, and I get that less is 16. And Marion was 4 years, 3/4 his age. So Marion equals 3/4 of 16. So she is 12. Number 18. Excuse me, 16. Let's skip a problem here. The denominator of a fraction is 9 more than the numerator. So the denominator equals 9 more than the numerator. D stands for denominator, N for numerator. If the numerator is increased by 3 and the denominator is increased by 3, the value of the resulting fraction is 1/4. So numerator plus 3 over the denominator plus 3 gives me 1/4. So I could use cross products here and get 4n plus 12 equals d plus 3. And then use substitution wherever I see a d. So I get 4n plus 12 equals 9 plus n plus 3. 4n plus 12 equals 12 plus n. Subtract n from both sides. I get 3n plus 12 equals 12. Subtract 12. And I think I have a problem. Okay, I found my problem. Let's go back and fix it. It said if the numerator is decreased by 3, and I increased it by 3. The resulting fraction is 1/4, so let's erase all this here. So now the cross products are 4n minus 12 equals d plus 3. Substituting in 9 plus n for d, I get 4n minus 12 equals 12 plus n. Subtract n from both sides. 3n minus 12 equals 12. Add 12. I get 3n equals 24. Divide by 3, and the numerator is going to be 8. And the denominator was 9 more. So the denominator equals 9 plus 8, which is 17. So my fraction, the numerator is 8, the denominator is 17. So that's my fraction. And the last problem, number 18. If the numerator of a fraction is increased by 4, the resulting fraction is 3/4. So if I add 4 to the numerator, do nothing to the denominator. The fraction is 3/4. If the denominator of the original fraction is increased by 2, in other words, do nothing to the numerator, but add 2 to the denominator, we now have a fraction that's equal to 1/2. Doing cross products, we get 4n plus 16 equals 3d. And here we get 2n equals d plus 2. I'm going to solve this one for d here. So 2n minus 2 equals d. And I'm going to substitute that in over here. So 4n plus 16 equals 3 times 2n minus 2. That gives me 4n plus 16 equals 6n minus 6. Subtracting 4n from both sides, I get 16 equals 2n minus 6. Add 6, we get 22 equals 2n. Divide by 2, and the numerator is 11. The denominator is 2 times the numerator minus 2. So that's 22, take away 2, the denominator is 20. So my fraction is 11/20. And it works because if I add 4 to the numerator, I get 15, which is 3/4. And if I add 2 to the bottom, I get 22, and 11/22 is 1/2. That concludes the evens. Be sure and check the back of the book for the odds.